Hey, everybody. Apologies, we had a little bit of a late start, so thank you for coming to the Automotive and Mobility track. Excited to see a bunch of faces of friends and a lot of new faces. Looking forward to meet everybody. My name's Dennis Liu. I'm the track lead. I'm an independent advisory person, helping clients ranging from startups to large multinationals navigate each other. I'm a recovering CVC and found this niche to be quite interesting. Previously, I've built and led Ford Motor Company, CVC, and excited how automobility has changed, and we have an entire track at a conference largely focused on AI. In my free time, I also help Startup Island Taiwan to help bring and empower founders from Taiwan to land in Silicon Valley, but also to attract interest for startups, corporates, and others looking to do more in Taiwan. And so it's my pleasure today to have Anil and Anantha. Anil is the co-founder of a stealth startup building inference systems for Gen AI and compilers for new chips. Anantha is the VP of ADAS for GM, here to share some great insights and thoughts on the space. As a broad overall rule, everybody, please let's keep it Chatham House rules so our speakers and guests can speak freely. And with that, please welcome our esteemed Fireside Chat folks.
Hello, everyone. Good morning. Hope we can keep it as engaging as Satya has done. That's a pretty high bar there. I'm very excited for this Fireside Chat with Anantha. Anantha Kancherla, VP of Autonomous Vehicles at General Motors. And a lot of stories we heard about General Motors, right? We heard about Cruise, autonomous vehicles, and now, I think autonomous vehicles, robotaxis are becoming a reality. So very excited to learn from Anantha about, hey, what's happening. So with that, great welcome, warm welcome to you, Anantha. Thanks for being here. So awesome, right? So our goal is to, we have prepared a long list of questions. We'll keep it like about 20 minutes conversation with Anantha, and like last 5 minutes we'll open for Q&A, if it's okay with you guys. So thank you, Anantha. Thank you for being here. The question, right, for me is, where is the future of autonomy, right? The last 15 years, a lot of things have been done. And where is GM placing its bets, right? One of the largest automotive company in US. Is it L3, L4, or full autonomy, right? What do these terms mean?
So maybe let me step back a little bit and talk about what GM as a company thinks about, and then maybe I can start the connection with the technology itself. Mm-hmm. Right. So Mary, CEO, the vision that she's put forward for us is internally we call it 0, 0, 0. So zero emissions, zero crashes, and zero congestion. And if you look at that, the two key technical pillars that will make it happen is obviously the batteries, the EV, and then AV, autonomous vehicles. So given that vision, so it becomes really imperative. So we strongly feel eventually L4 and L5 even is going to be what will realize this entire thing. Of course, GM put its money where its mouth is. When before this was a big deal, GM invested in Cruise. Mm-hmm. GM, I wasn't there at the time, but Super Cruise was launched, which is at that time it was crazy advanced, and even today it keeps winning awards. So this year we got the award from Motor Trend for the best automated driving solution there. Mm-hmm. So it's hands-free. So GM has always been focused on trying to push the frontiers of it in what is capable. But of course, L4 and L5s it'll be a march towards that. It happened already in some cases, but of course, our focus is to sell cars. It's about solving car ownership problems. Mm-hmm. And then what are all the things that people have when they drive cars? So you want to be safe. Mm-hmm. You want to feel comfortable, when you're driving long distances, say you're going on a ski trip to Tahoe, you want to not be tired when you get to the ski to the slopes. You want to be able to do other things while you're in the car, and perhaps you might even want to send the car to go pick up your kids or your wife from the airport. So there are a number of these scenarios that you want to tackle, and each one of them will have a certain amount of technology that needs to be built in, right? Like, so some of them will require L4, some of them will, you're probably okay with L3, and then like L2. So I think like in our case, like we kind of look at the entire thing. So we focus on, obviously we want to get to what is the ultimate car ownership thing, like you send a car to pick up somebody. But we also want to solve the places where like people want to drive and they want a guardian angel looking over them to make sure that nothing bad happens on the street. We also want to make cars, which we already do, to give you a comfortable drive so you can drive long distance, and it's still like not a big deal like when you're traveling for your vacations.
Cool. That's very interesting, right? The guardian angel, right? That's that gives me comfort for most of my driving. And once in a while, I want to pick up, the wheel myself, and that's perfect. And how does this, this thinking compare with what Waymo is doing and the robotaxis?
So it's a fundamentally different product. So the product that you see right now in San Francisco area, and I think like they've started also in Palo Alto now, is a taxi. So it's no different than like Lyft or Uber. The difference is that it's a robot driving it instead of a human being driving it. So actually, it's funny, like before a few years ago, my journey into automated driving started at Lyft, where I was, we were starting that, we called it Lyft Level 5. And my story used to be that we already make a car that you don't drive. Like you just get into the car and like somebody's driving you. So our job is like to turn it into where we can scale it, like by not having a driver, but a robot driving it. So that's what they're building. But what we are building in GM is a car that you can own, that you can, like the way you do it always, but like that you don't necessarily have to be driving if you need to. So it's like the requirements are quite different. Like, so for example, if it's a taxi, you're okay, like having a sign of a taxi on top or like a festoon with a whole bunch of like sensors. Whereas if it's a car that you own, you probably want it to be like much more sleeker, built in. You don't want things sticking out. You don't want like extremely expensive calibration processes and maintenance that comes with it. So
cool. So this is very interesting, right? And what does it mean for the technology stack, right? The AV stack, like what has been done in past and how it's evolving,
Yeah. So maybe like for those of folks who are not like fully familiar with like how this works, maybe I can just like give a brief outline, and then we can talk about like how the technology is evolving and where it's going. So first of all, a self-driving car is a robot. And if you heard like what Satya was just saying, like the next big frontier for people in the space of AI is like he's talking about like AI in the physical world. That's what this is. So now all robots, they generally tend to have this. This is oversimplified, so but I'm just like simplifying it for the sake of understanding. So this concept called SPA, sense, plan, and act. So the robot senses what the world is, and then it plans what it needs to do, and then it acts on the plan. And this is actually the same journey, ironically, like the LLMs are taking also, because the whole notion of planning is like something that they're trying to get better at when they say agents, agentic AI. That's what this is.
Yeah, I would like to touch on the topic too.
We'll get there. It's a pretty interesting area. And so now, this whole wave of self-driving started like when the first big breakthrough in deep learning happened. So when convolutional neural nets showed up. And then the people suddenly started realizing that like, oh wow, so now I can basically like throw a lot of data and do data-driven programming to perceive the world. So and then that became like the perception, like understanding what the world looks like, became AI-driven, if you will. These days, of course, AI means different things to different people. But in my mind, like AI is like anything which is like data-driven, and and these days, of course, neural net-driven. So then that became like the AI. So Super Cruise, for example, so the perception is machine learned. It's AI. So we use Mobileye for that, but essentially it's that. Like so, it's doing the perception. But past that, the planner or the control systems is just very simple. Like it's rules based, and the planning tends to be the control tends to be like your classic controls systems algorithms like PID controllers and stuff like that. So now over time, like so, then what we were doing at Lyft or like what's Cruise and all these like robotaxi wave of technology that started happening like from then onwards is AI started penetrating deeper and deeper. So can I do tracking using AI? Can I start doing planning using AI? And can I, and all of those were enabled with the next big breakthroughs in AI. So when transformers happened, people started like looking at that as a way to use, to do prediction of the world. How is the world going to change? And it's like the way you predict the next sentence, next word in the sentence, that's what LLMs do.
Yeah.
So that's what the cars do. Like they're like looking at the world and then they're like trying to say, what will happen next based on everything that I've seen before? And so use very similar techniques to go to the, to understand the next frame. And so that that's, I would say, like is the current state of the art. But where things are going next is you will hear the term end-to-end AI or foundation models. Basically what these are is these end-to-end means like, so today if all these cars are built with like lots of small models that are strung together with a lot of human engineering. So anytime like you do human engineering, so some assumptions are made by the engineers about what data is important to the next model and what is not. And that ironically tends to lose data. So what people are now really looking at is like, how do I like actually pass all the way through, and you given the sensor input and the output is like a trajectory that the car can drive. So that's that's where like things are headed, and that's where where both like self-driving as well as the broader robotics are going to. And then you'll also hear the term foundation model.
Yep.
And what foundation model really is so like unlike in the world of LLMs, where you can, like the stuff that you're doing, like you build a giant data center and like just run like massive number of GPUs and LLMs on that. That's not possible in a car.
Exactly.
Like or in a robot.
Efficient.
Yeah, it's not power. You have to be power efficient and all that. So what people tend to do is that you will train like a big giant model that understands everything, but then you distill it down to something that can run on the car, but it has the essential capabilities. So that's why you'll hear the terms end-to-end and foundation model as a direction that like this world is taking.
This is very interesting, right? I think what now the venture world, and of course Jensen started this, right? With this physical AI, automotive autonomous vehicle industry has been working on it for the last decade. Right. And as someone was saying, right, I don't want the AI to write poems and poetry. I want them to do the work while I sit and write that, and that's exactly what you guys are doing. You're sitting and building that, right? Talking about that, right? So, do you see like hey, LLMs being used in the vehicle? Probably the typical Gen AI that we talk about,
So, well, yes, and I think that clearly, like there is a use for an agent in the car. Like you can think about it as like a way to interact with the car, right? So there is a place for. So today, what LLMs are doing is that LLMs are really good at. It's a different user interface. So I just think about like the vast majority of the work that's happening as changing the user interface from UI to AI. So that's basically, I think maybe Satya also said that in the previous talk. So that's the big change there. So that change in how you interact, that's a pretty obvious place. Then there are other aspects like what LLMs are going to, like when they talk about reasoning AI. So there is a bunch of reasoning kind of stuff that is needed, like whether you're diagnosing the problems in your car, like maybe not while you're driving, but for the mechanics, and or designing the car. Like there is a lot of opportunities to apply, and then of course there is manufacturing of the car. So that's another place like where there's lots of opportunity to apply AI to solve those problems. And of course, like it goes without saying that. The techniques that I'm talking about are essentially the same thing as like what an LLM is. It's just the data. So, in fact, in our world, we call them VLAs these days. Like a very common word, common phrase that you'll hear is that the models are VLAs: vision, language, action. And that's exactly that. Like, so the core backbone inside it is a traditional LLM style thing. And you take in like various sensor inputs. That's why it's called vision. It can even take in language inputs. You can say like, explain to me why you did this. It should be able to explain to you. And then there is action, which is like the result. And again, another similarity or differences you'll see. In some areas, this robotics world or self-driving world has been more advanced. Like, for example, the use of reinforcement learning. That has been like much more common in our world. Now they are doing that, like, with all the DeepSeek and the current model of GPTs. They're doing a lot more reinforcement, and not just like RLHF, but like just the reinforcement. RL, but in other areas they were more advanced. Like, so the LLMs were like really, why they became so big was because they started using unlabeled data to do self-supervised learning. So self-supervised learning means like you just keep giving it the data and then it just observes the data and then learns. It's kind of like how we learn as people. So in the past, a lot of the driving or robotics was done with supervised learning, where what it meant was like you collect a lot of data and then you still have to label it, annotate it. And that's very expensive because you're pulling in lots of human labor into it. But where we are headed is exactly that, like, which is like you let it observe and then it figures out like what it needs to do.
Perfect. So, this is very interesting, right? I think, we can go hours into the technology, but let me change a little into the, how the leadership and reflection, right? You've been at Meta, you went to, Autonomy at Lyft, and, Meta, and now at GM, right? And I'm really excited about that, right? I think, when I think about the traditional automotive, most of the leaders typically come from automotive industry, and you're one of the few who are taking a lot of the learnings from Silicon Valley, not only Silicon Valley, from one of the top tech companies to automotive industry, right? How do you see the transition, right? How is the, both in terms of, how you're bringing the culture and, how it's helping in the innovation?
Yeah, a great question. This is what I every day, like I wake up and think about, because it's certainly not easy. Because so maybe I should just step back a little bit. I think there are two big factors that we need to think about. One is the type of product and the maturity of the company. Those are two huge things that play a role in like the culture. So, for example, Lyft. The entire effort was a startup. Like, so you're going from 0 to 1 to maybe 1 to 10. And it's a very different style of building a team. And lots of mistakes are tolerated. So that like you have to innovate. And innovation is all about taking risks and figuring out how to get things done better. And you don't really worry so much about like cost. Like you're just like really very rapidly iterating and trying to get to the right place. So it's a very, very different style of team building and operations execution that you need to do. The metrics that you look at are different. In a place like Facebook, it's already found product market fit. The problem there is like, how do I like scale from 10 million people to 100 million people to 1 billion people to, like the entire universe. Like, so it's like a very different style of thinking, because there you already have a product that is very successful. Then every time you add like an order of magnitude more customers, the kind of work that you need to do, you need to like radically reinvent your product and technology. And, but at the same time, like you want to do it fast, like so that it scales up. But clearly, you don't want to piss off like your old, the customers. So the balance is different. Like, so it's still kind of, you would say, somewhat like preserve some things, but like you go there. In a company like where you manufacture, it takes time to build a factory. It takes time to get the supply chains working, and it takes time to like get all of that working. So in that sense, if you suddenly like decide on a whim to change, like, hey, I don't like this, I'm going to change my sensor. Oh boy, like now you have to go all the way back, and then they may have to redesign the car. They may have to redesign the factory, like, or some aspect of the factory, not the whole factory, but like some aspect of it, they may have to like go get like different sourcing. Even like something as simple as changing a bracket because you have a different radar is going to have like ramifications. So you have to think a lot more like before you make the calls. So that's a different style of execution. But all that said, the power of software is exactly what it is. It's malleable. It can change. So then the thing that like we need to do in these kind of industries is how do we set ourselves up to be more general purpose. So I'm perfectly fine like if I don't write all the software, but at the same time like I want to have the ability to write any software that I want. So then you turn that into a more of a style that like say a Meta or like a typical tech company operates. So this means like a lot of the understanding needs to be brought into the company about what is the strengths and what are the weaknesses of software. Because if you don't know, if you've not worked with it all your life, you're going to be fixated on the weaknesses quite often because you'll be like worried, oh boy, you can change it anytime? What will happen if it breaks? Yes, it will break, but there are also ways to not do that. That's how like, all these services that we depend on every day work. So then how do you engineer it to get to that point, and how do you reason about like building your team to take those risks? And what so much of it comes down to is actually this is another thing that like many times I talk to startups, like it comes up is actually focusing on your internal developer tooling. And when you start like paying attention to it and don't treat it like a cost center, it's IT, then you have a different attitude towards like trying to figure out how to turn that into it. So I don't know if I answered your question. It felt a little bit rambly, but I'm just like trying to make the connections between the type of company it is, the type of product, and then the age of the product, and the changes that you need to bring into it.
At least I'm getting a feel that you're being heard, and coming from Valley, right? It's always challenged to go back to a traditional industry, especially in like Detroit and.
Yeah, I mean, one of the reasons why even I took this role on was because exactly that, like because it felt like there is a genuine desire to embrace change. Fantastic. And it's of course one thing to talk about change and one thing to embrace it. But then I've always seen like GM has taken those big leaps. Like years ago, like they built EV1 like with a battery. Like when I first came to the States, GM had at the time bought a company called Hughes Satellites, and they made the first connected car. That was kind of crazy when you think about like 1990s to have something like that, or even like a first battery electric vehicle, like which could where like you can use the battery and then the vehicle like volt. So or investing in Cruise itself. So it's always been like pretty on the cutting edge. So it kind of felt like this is a company that wants to do the right thing. Fantastic. So it kind of felt like, okay, I think it's possible to make these transitions.
Awesome, very excited, right? Probably we have time for one question.
Hi, my name is Sushil. My question is surrounding connected autonomous vehicles. Okay. So you're well aware of when I saw ADAS up there. All these V2X technologies, and vehicle is connected all the time to the network. Few years ago, when I was working for Dheyo Corporation, we were dealing with a lot of challenges around cybersecurity and getting the access into the vehicle. Right? A lot of technologies were talked about at that time. You can have SSH sessions and things like that. But it was still, in the last few years, still, I have not heard any new advancements to cater to that challenge.
To which one? Which particular challenge?
To be able to have protection against cybersecurity, cyber attacks. Like somebody can actually log into the vehicle. There's an autonomous vehicle, right? It's connected to the internet. What kind of advancements have happened in the last few years, or how GM tackles that challenge?
We take this extremely seriously. So this is like a big focus. We just like brought in Mike Hanley, who's our head of cybersecurity. He came from GitHub. So he was the CTO of GitHub. So we are bringing in like the best of the best here. So, and through Cruise, the famous people who did the Jeep hack. So who like I know if you know what I'm referring to.
But
so
technology-wise, what kind of?
So it's a less of a I don't look. I'm not a security expert. So it's hard for me to like explain the specifics of like the technology that they're working on. But the point is that if it is an important problem, the technology exists. So it's a matter of like bringing that into the automotive. And that's exactly the same journey that the security side of GM is going through. Like trying to bring the same technologies that like we use in order to be able to secure our bigger services to make a car work safely.
All right, sounds good. Thank you.
Cool. Yeah, thank you guys. Thank you, Anantha. Thanks for a wonderful conversation here.
Thanks, Anil. Great to be here.
And Anantha will be around, and of course there'll be more amazing talks where you can have this further discussion. Dennis, where is Dennis?